Listen, this is why all the robots are different. Each one needs to do one task really well. Now, humanoid robots, like George here, are super fun and exciting, but can you get the job done? So let's talk about what different NXP solutions would be used to build these different types of robots, like the humanoid robot, or a mouse robot, or a wheeled robot. Ian, let's start with your ideas.
Well, certainly we've got a reference solution here. This is our B3RB, Buggy 3 Revision B, and it literally is a complete design, an Ackerman steering vehicle. So this would be an example of something you're making an agricultural robot that's got to go through the rows of potatoes in a field, with a intelligent companion computer, but also real-time control running on a Zephyr operating system and model predictive control for this type of vehicle architecture. So we provide all that as a complete reference starting solution with T1 automotive Ethernet and CAN bus and connectivity, GPS. It's really ready to go to make this kind of mouse bot.
Great. And then what would be the job of a mouse bot?
Well, I don't know, delivering mail, but in practical terms for today, an agricultural robot's a really good example. Driving down hallways, anywhere it needs to navigate in a way you would normally navigate a car or that kind of vehicle.
And you talked about NXP components in here. Can you point them out again specifically?
So this is an i.MX 8M Plus processor. So it's a Linux machine with neural acceleration, video camera input, image processing pipeline, and that's sort of your brain of the operation. And then we have a real-time controller. In this case, we're using an automotive part. It's a dual-core lockstep part. There's security components in both, and they communicate with each other over a single twisted pair 2-wire Ethernet. So those are lots of NXP components. And then on the motor control side, we've got a few options here with some of the both industrial parts, MCX, and S32K1 motor controllers.
Let's now talk about my best friend, George here. How would we build this with NXP solutions?
So this is a very simple looking humanoid, but in reality, when customers are building humanoid robots, they tend to be very complex designs. There's a lot of motors that go into a humanoid. If you look at, the amount of joints and freedom of movement that you have in your hands, fingers, wrists, elbow, they're trying to replicate that capability in a humanoid robot. So the number of motors you need and being able to synchronize that movement so that it can be stable in any one of those movements, because to humans it becomes intuitive, but to a robot you got to basically program that and teach the robot that. So that's a complex requirement. And for those motor controls, the communication between these, this has to be a very lightweight. You have very little room for cabling, through all these joints as well. So we do use like the T1 Ethernet that Ian was talking about. This is just one example. It uses a 2-wire Ethernet. This is actually just showing you from an RJ45 to a T1 interface. This is actually an Ethernet switch, so it would act as a hub, and you would have these connectors that connect multiple different modules on a network as well. And also because of the speed at which you need to synchronize these motors, they tend to have both motor control and motion control. So the motion controller basically synchronizes the movement across all these different motors. And also they use specific industrial protocols like EtherCAT or TSN because they want low latency synchronized movement for these robots as well. And then you also have technologies, like Ian mentioned, for vision, for perception. Something like the i.MX 8M Plus that Ian mentioned has both the vision capability, so that can act as that vision processor. It can bring in that sensor fusion. We can also have from NXP things like, radar technology that can do 4D imaging and mapping as well. And we have high performance processors that have both vision and safety capabilities as well. So those kind of things can be integrated into these solutions. But a humanoid is a much more complex architecture, but the building blocks and the technology you need is very similar. It's just scaled to a different level.
Exactly. Okay, let's talk about the rolling robot now. And what are some things that are a little bit different and building for this versus the previous two robots we talked about?
Well, what's really cool here is, we've enabled this with very standard tools, Zephyr and ROS and the networking components. And because of that, it can run on different hardware. So here we have an automotive grade processor. Here's an industrial processor with inertial measurement sensing built in. And a rolling robot may need that. And it also has the motor control, but it might not need to be an automotive grade processor. So that's certainly a difference. And another thing coming down the pipe is this i.MX 8M Plus. We'll soon have the i.MX 9.5, which we can integrate some of these things together, as well as supervisory control.
Interesting. I see a theme here across these three types of robots. They all need processing for the brains, connectivity or interconnectivity, sensing, and control, like motor control. Is there anything I'm missing?
Yeah, I mean, keep in mind, NXP has a huge portfolio, including things like battery management, right? So here's a very customizable battery management board reference design that lets you do all kinds of control over what's happening with the robot battery. So
Great. And we just kind of touched the surface. So Ian, how much deeper can this get?
So actually, that's a good point. I mean, we have a nice white paper just released, and I think it goes into a lot of detail and shows you the breadth of the NXP components that are applicable to mobile robotics in there.
Thanks, George. For more conversations at the edge, check out our links below.